We will now discuss the conditions under which an object will remain in a state of equilibrium under the action of several forces. Now, this object is in a state of equilibrium. This mass is in a state of equilibrium under the action of two forces. What are they? The weight of the object is acting vertically down, and the normal force applied by this marker is acting vertically down. We say the sum of the forces acting on this object is zero, keeping this in a state of equilibrium. Now, is it possible that I can keep this ruler in a state of equilibrium on here? You can see it's, well, it was almost in a state of equilibrium before it slipped off. Is that right? Well, I can, with some perseverance, yes, this is in a state of equilibrium. What are the forces acting on this ruler now? You can see, once it is in equilibrium, I can move it around. What are the forces acting on the ruler when it is in equilibrium? The weight acting downward and the normal force acting upward. That makes the sum of the forces acting on the object zero. Now, what are the forces that will keep this in equilibrium? Now, watch this. I'm holding this mass by means of this string. Now, I want you to discuss the conditions under which this point is in equilibrium. What are the forces at that point? There are three forces at that point. Can you tell me what those forces are? One is the tension on the string on my right hand, the tension of the string on my left hand, and the third force is the weight of this mass. And all those three forces are acting at this point. Now, that point is in a state of equilibrium. Why? Because the forces are balanced. So, an object may remain in a state of translational equilibrium. In other words, it doesn't move in the x, y, or z directions. Translational equilibrium, if the sum of all the forces in the x direction is zero, the sum of all the forces in the y direction is zero, and the sum of all the forces in the z direction is zero. Well, tell me, will an object remain in equilibrium if the sum of all the forces acting on it is zero? Well, now look at this rod. I'm going to apply a force upward on my left. Well, on my left will look like your right. So I'm going to apply a force upward here and downward at the other end. The equal forces. I'm going to apply equal forces, one upward and the other downward. Well, the sum of the forces is zero, but is this in equilibrium? Let's see. Look at that. I'm applying a force downward here and upward on the other end. Is this in equilibrium? And I change the direction of the force. Is this in equilibrium? No. Therefore, what is the condition that you need to be satisfied in this case? Well, the force I apply on the right side upward produces a torque. Is that right? It produces a torque. What is the direction of that torque? You see, that torque is rotating this rod in the counterclockwise direction. It is a counterclockwise torque. And the force that I apply downward here is also producing a counterclockwise torque. That means these two torques will add up to give you a net torque. If this has to remain in equilibrium, the net torque has to be 0. So, before we write these things down, let's talk about this one more time. When you talk about equilibrium of an object, the objects may remain in a state of equilibrium with respect to translational motion, also with respect to rotational motion. In order that an object may remain in a state of equilibrium, the object should not be having any translational motion. That means the sum of the forces acting on the object must be 0. Also, the object should not have a rotational motion. That means the sum of the torques of all the forces acting on the object taken about any point must be 0. Now, before we go on, let me see if I can draw that situation for you. If I have this is the object I have, a force, say F1, acting on this can produce a rotation on this object about this point A. The force is acting at the point B. Now, what is the torque of F1 about point A? Now, when I say the torque of F1 about point A, what I actually mean is the torque of the force F1 about an axis that passes through A. Now remember, rotation always happens about an axis. Is that right? So we want to find the torque of this force F1 about an axis that passes through A. What is the torque of a force about an axis? It is the force multiplied by the perpendicular distance between the force and the point. Therefore, this torque is the distance AB, that is the torque arm, multiplied by the force F1. Now tell me, what is the direction of this torque? A torque can produce a clockwise rotation or a counterclockwise rotation. I'm sure you can now distinguish between these two. Tell me, what kind of a rotation is this F1 producing about this point A? Watch my right hand. Well, my right hand will look like my left hand for you. Now, I'm going to point at A. That is my fulcrum. That is where the axis of rotation is. Now, look at the way F1 is going to rotate. The F1 is going to produce a rotation in that direction. What kind of a direction is this? This is counterclockwise. Counterclockwise. Alright? So we say the force this force F1 produces a counterclockwise torque about the point A. Well, suppose I have a force F2 at the point A. Tell me, what is the torque F2 can produce about the point B? When I say about the point B, I mean about an axis that passes through B. What is the torque of? Let me see if I can write it with this. What is the torque of F2? Torque of F2 about the point B. The torque of F2 about an axis that passes through B, it will be the torque arm AB multiplied by the force F2. AB multiplied by the force F2. Now tell me, what kind of a torque is this? If I now hold my finger at B, that is the axis, and rotate the rod using the force F2, look at the way the rotation is going to take place. The rotation is going to be like this. It is a clockwise rotation, isn't it? That is the direction of motion of the hand of a clock. That means force F1 can produce a counterclockwise rotation about the point A, and force F2 can produce a clockwise rotation about the point B. That means these two torques oppose each other. So if one is positive, the other will be negative. We can choose which torque you want to call positive and which you want to call negative. Now for convenience, we're going to call the counterclockwise torque as positive and the clockwise torque as negative. So when you want to write the torque of force F1 about point A, it is a counterclockwise torque. Therefore, it will be positive. If I don't put a sign there, it means it is positive. Whereas the torque of F2 about point B will be a clockwise torque, and that will be negative. So I will now use the negative sign. Tell me, what is the sum of the torques due to these two forces? What is the sum of the torque? In other words, what is summation of tau? Is add these two torques. And if the forces are of equal magnitude, this sum will be 0. Now, if the sum of the torques equal to 0, that means the object will not rotate. So, now tell me, what are the conditions under which an object will remain in equilibrium? The conditions are the sum of all the forces acting on it must be 0, and the sum of all the torques of all the forces. Now watch the sentence. The sum of the torques produced by all the forces taken about any point must be 0. Alright, let me try to explain.